Behavior is the essence of good gameplay. So how do we manage it? Hi, my name's Andrew Mengade. I'm from Get Into Game Dev. I'm an independent game developer working in GameMaker as well as custom engines. In this video, we're going to talk about state machines, finite state machines. This is a pattern which will take your programming and let you scale it up to a really high level. As an example, imagine we've got a character. And this character can do a bunch of things. We can run, we can jump, we can shoot, we can die, we can do whatever that is, but we need to manage the update logic. A naive approach is basically to put in a bunch of if statements. If some certain thing is happening or behave some way, there is, though, some overlap between states because we might be running and shooting at the same time, in which case some of those if statements will start to smudge, start to leak into each other. And also it just becomes a really big tangled mess. A pretty good next approximation is to have a state variable which tracks which state our character is in, and have a bunch of if statements, have a bunch of switch statements. By the way, I'm demonstrating this in Python, but this will really work in any language, even game engines. I've done this in GameMaker, it works just fine. Now, this is fine and this is correct, but there's two issues. Number one is that the functionality becomes quite big because we are inserting all of the code for all the state checking in the same spot. That's a very big if statement or switch. And number two, there's still the possibility that some bit of state that we set, some variable that we set in one state could leak over and interfere with another state. So enter the state machine. Here's the code for an abstract state class. We can basically do three things. We can enter into a state, we can work in the state, and then we can exit out of the state. Now, the really powerful thing is that enter and exit statement, because what that does is it ensures that we can switch from one state to another without knowing which state we're going to switch into and having the guarantee that one state is not going to interfere with another state. This lets us compose things and get some pretty cool behavior set up. And here's how we can set this thing up in practice. So we can construct a class for each of our individual states. Each of those are extending or inheriting from the superclass. Store those states in some sort of lookup table, keep that variable which tracks which state we are in, but then at the update time, we don't need to do any checking. We just know that we have a valid state, so we run that state. That update function will return the state that we should transition into. If it's not the sentinel value to not change, then we go ahead and change. We exit out of the current state, switch over to the next state, enter into it, and that's it. So the secret power of a state machine is that it doesn't just have to apply to little characters that run around and do booty dances. It can also be extended to the gameplay systems themselves. So we could have a renderer class which renders things in different ways depending on which mode the game is in. And it's very flexible and it's very easy to switch things around, and all of the logic for that behavior is contained in its own little box. So I hope you enjoyed this session, and yeah, see you around soon. Behind the scenes, Andrew here. I just wanted to give a really big thank you. I hope you enjoyed the video. I'm trying to put a little more effort, make it a little more artistic. If you would like to support the content, if you like what I'm putting out, I've got a Patreon, links are down below. Also got YouTube memberships. And as always, really big thank you. I really appreciate it. What would you like to see next? Drop a comment down below. All right, well, that'll be it for now. Have a good day. Bye.